Hi, and welcome to the next episode in this tutorial series where we implement the FBX SDK and do some follow-up on the renderer in this series. As I've mentioned, these tutorial videos are recorded during a live stream, so sometimes accidents happen and we don't end up in a totally working state, but we'll give it a try. So last episode, we got the model loading using the FBX SDK. We implemented it. We implemented it in a somewhat naive way here, but we will do something else in order to actually load this stuff here. So let's comment out a lot of this stuff here because we will redo bits of it. Yeah, so let's see. Let's do a const int face count, which will be our mesh get polygon count here. And we will do a FBX vector vertex positions and this returns a array. And let's do a const int vertex, or rather, I'm not sure whether we should call this control points and then just to use the get use the terminology used by the FBX SDK. Yeah, and let's do an unsigned int. And let's do a polygon iteration here for all of the face counts here. Maybe even just a face plus plus. And let's do a const face vertices vertex count. Let's do mesh get polygon size for the face here. And then inside that we will do int face vertex and face vertex less than face vertex count here, and then face vertex, and let's do a int const int control point index, polygon vertex, add our face and face vertex here. And let's do a render vertex here, I think vertex. So the vertex position should be let's see. Let's do const reference position data equals control points. Let's do control point index here. And let's do a position here where we, of course, cast to float position data 0, 1, and 2. And let's do a const int normal count, get normal, rather get element normal count, and then int normal count here, and normal element plus plus. Oh, I forgot this as well. Okay, and then let's did we, yeah. Let's see. Normal, key normal. Let's see. And let's get the normal. Let's see. Let's see. So we want to let's see. Let's see. Let's grab our normal. Let's see. Normal data here. Get normal, p normal here, and let's use our vertex count here. And then we set our vertex dot normal equal to something like this, but with our normal data instead. Yeah. So, and then we have our vertex. Let's do a series of uh, um, data structs here that rather contains our uh, um, let's create a vector here of our vertices, mesh vertices, and let's do, we find the normal, and this is outside the scope of this, so this will contain the actual vertices. Then we check if the current vertex, let's see, let's do a const size t mesh vertices equals mesh, oh, mesh vertex count dot size here. and then do a for loop here, int, or rather size t I equals 0 and 0, or rather I less than the mesh vertex count here, and then I plus plus. And let's see if we can create a function here. Bool compare vertex render vertex reference A render vertex B here, and if A dot position, can I do this? B dot position, can I compare them? No, I can't. DirectX Math doesn't have a comparison for this, so let's do x equals x. Let's do the same thing for y. And let's do the same thing for c. If then all of this, instead of the position, we do normal here. Then if this is the case, we will return true, otherwise we will return false. So we simply check if these vertices are the same, and we will then check if compare vertex. Let's see. Oh, this is supposed to be inside here. Vertex and mesh vertices I. If we have it already, we break. Oh, we want to and make sure that this is 0. Because if we find a vertex, it's not unique, and therefore we will break this loop, and then we can check if the I ever reached the mesh vertex count. And if it did, we will do mesh vertices, push back, or rather in-place back our vertex here. And then let's also create a vector here, uint32 mesh indices. And I think it's just the face value, right? Yeah. I suspect. Or rather, no, since we computed the I, it's of course that one. Okay. Mesh indices dot pushback the I value here. And then vertex, or did I vertex plus plus, right? Yeah, so okay. let's see what we end up with. And let's try removing all of this. Whoops. And let's see. Okay, so we have mesh vertices and we have mesh indices, which looks like something that we actually want. So we now have computations of our unique vertices, and we can simply move. Right now it doesn't support it. It only loads one geometry. But I leave that to you as a potential fix. So out vertices equals to std move mesh vertices, and let's do out indices move mesh indices. There we go. And immediately you see two triangles here. That means that we actually have created some data. Should we implement several meshes? Okay, let's couple this to the actual renderer. So the model loader should return a set of draw parameters. Yeah, I'll leave the implementation of the extra models until later. If you want me to do it here on the channel, feel free to do that. Maybe we want. Okay. So what we'll do is something like struct mesh draw data, which will be a maybe a UN32, just to keep our stuff in the same order, I guess. UN32 vertex count, UN32 vertex offset, UN32 index count. Let's do index offset. Yeah, and our renderer API here will actually have a vector of meshes, mesh draw data, meshes, which we will then actually pass as an argument to our model loader here. Out meshes. And we will pass out the meshes here. Let's do Is this in renderer? Yeah, I think so. Render. Yeah, so and let's see, this is our mesh, right? No, this is our mesh. So this is actually what we want to. Oh, yeah, okay. So this only right now supports one mesh. Let's see. Just a sec. Let's see. So, yeah, we want to compile our mesh data here, render mesh data, and mesh draw data, which should be the. Okay, maybe I should just implement the multiple mesh stuff anyway, and as we're currently doing it, so mesh vertices dot size mesh draw data index count mesh indices dot size. And let's do a value so it's not related to this. So outside this, we will actually do something like total vertices uint 32 total indices. Let's see. Let's do an unsigned, or rather maybe a size t. Vertex offset and size t. Index offset. Yeah. Usually we don't need. Oh, the vertices. Oh, yeah. I think we will need both. Index offset here. And let's do the draw data here. Let's do index offset. Vertex offset. Let's move this. And at our out meshes, we place back this mesh draw data here. And this will simply create our draw calls. Let's do total vertices. Whoops. Total vertices. Can I do? Whoops. Oh, I have. Oh, I don't use these. Insert at the end of the end here, and then let's do mesh vertices that begin, mesh dot vertices dot end. Right, and let's duplicate that for our total indices, and let's do mesh indices. There we go, and this should actually okay. So this should actually allow us to load several models in the same Blender file or FBX file that is. And let's see, let's do M meshes. And let's do this. Okay. We have some trouble. Let's see. Render. Oh, I need to actually specify the namespace here. Okay, so we have on our render API here, we have our meshes which are 0, and now we should have 1 with a vertex count of 24 and index count of this. So let's do a implementation down here when we do our draw calls. Yeah, so let's just access. We need the, let's convert this then. Draw index instance count per instance. Okay, let's do meshes. And let's grab our first mesh here. Let's do index count here then. Instance count is still 1. Start index location meshes. Maybe even let's do render draw data pointer draw data equals this, and let's do draw data index count, draw data index offset, vertex offset, and then the start index location, or rather instance location. And let's copy this for our draw calls here. Okay, let's see. And we're back to rendering boxes. The normals are apparently flipped though. Let's try swapping the winding order. So where do we create our pipeline? Our pipelines. Let's see, pipeline here. Let's do false for this, maybe. Yeah. So the winding order was wrong. Alright, let's see one more cycle. Yeah. So this basically uses the FBX SDK to load our models now. We could, of course, do something more interesting with it, but rather than a cube, let's try actually, well, yeah. So right now it loads all of the meshes inside the FBX file. So let's open Blender and let's add a series of meshes here just for testing. Let's create a mesh here where we extrude this and extrude this and extrude this, and then something like this, I guess. This is our mesh 1, and then let's add another mesh here. And let's hide the old one, and let's do some editing on that. Let's do like this, and let's export the FBX, and let's set our C as forward here, and let's triangulate faces since we're not using quads. And let's replace that. Okay. Now we should see, hopefully it exported them both. But let's see, let's add a breakpoint here. And yeah, we have several meshes, I think. Yeah. So the first one has a vertex count of 87 and an index count of that. And then the next one, of course, has the offsets and stuff like that. Okay. So everything gets loaded. Let's see. So we have our model here. I'm actually unsure if which one is which. Yeah, definitely our shadows are not right, but that's not the point of this tutorial here. Okay, so when we do, yeah, we will fix the shadow stuff since we're implementing shadow mapping. Okay. Let's see our draw call, draw floor. Let's do second one. Let's not draw a floor. And then we have the planar shadows here. Let's not draw any of this with our shadows. Okay. So we won't be drawing shadows. And we can see that we have two different objects. I remember this being different. If we look into this, we have this one, and then we have the L. And this is obviously a non-uniform L, and the other object is something different. So it works. Yeah. So we can load several models now by simply creating a Blender scene with several models and use FBX to actually upload that to our GPU and compile some draw calls in a sort of mesh database. So yeah, right now our what do you call it? Our shadows are messed up, but since we're moving this renderer in a different direction than it's previously been in, I won't mind. So yeah, we fixed the problem that was happening in the previous episode where we had to recompile the unique vertices when we load our model. That we do. So now we end up with, for a box, we end up with a total of 24 vertices and then 36 indices, which is something you would expect from a cube that has vertex normals. All right. So this is actually part one of the FBX part of this series. So next we will create some deferred rendering, and then we will move on to shadow mapping. Yeah, if you found this helpful, entertaining, or inspirational, please consider commenting, liking, or subscribing. Check out the description down below um, um, in order to figure out either to how to get the code or uh, join the Discord server or support the channel. Anyway, thanks for tuning in this episode, and I'll see you in the next one.